today we're going to take a look at how to do normality tests on SPSS. So it's important to assess for normality because it's often an assumption of many different statistical tests. So we need to check that the data are normally distributed in order for the tests that we subsequently run to be valid. It's not an assumption of all tests, such as non-parametric tests, but it's an assumption of many tests. So it's important to learn how to check for normality. Specifically, we're going to look at how to do KS tests, Shapiro-Wilk's tests, and we're going to take a look at how to interpret histograms. So these are very common ways of using SPSS to determine whether data are normally distributed. So for this example, this is the data set we're going to work with. So it's a data set about how many bowls of food different animals eat. And so we have dogs in this data set, we have cats in this data set, and we have male dogs, male cats, and female cats. And in this column here, this is how many bowls of food that those different animals eat. So one thing we can do is just look at whether the data for the food eaten variable is normally distributed, regardless of which group we're looking at. So looking at all the data together and ignoring whether the data come from dogs, cats, males or females. So to do this, we can go to Analyze and then down to Descriptive Statistics, then across to Explore. And the default would look like this. So I'm just going to transfer food eaten, that's the dependent variable, to the dependent list. I've got both checked down here. I'm going to go to Plots, and here I've got histogram ticked. I don't have stem and leaf ticked, and I have normality plots with tests selected. So I'm going to go to Continue now, and then I'll go to OK. Okay, then I'm going straight down to this tests of normality table. So we've got these two tests of normality here. So we've got this Kolmogorov Smirnov test, and we've got the Shapiro-Wilk test. There's no exact rule about which you should use, but typically the Shapiro-Wilk test is used when you have a smaller sample. So for example, if your sample is less than 50, I'll put a reference to support that down below in the description. And so then you would use the KS test more often when your sample is a little bit larger, so above 50. Okay, and what we're interested in is the sig values for both of these tests. And what we want to see is that the sig value is actually above 0.05. So that would indicate that the test result is non-significant. So in the case of normality tests, we want the test result to be non-significant. So in the case of this KS test, we can see that the value is above 0.05. And so that indicates that the data are normally distributed. Same thing with the Shapiro-Wilk test. The sig value is above 0.05, so it indicates that the data are normally distributed. Okay, if we go down to the histogram that is generated through the process we completed, we can see that this histogram basically supports the normality of the data because this histogram has a nice symmetrical pattern. It looks a bit like a bell, which is why this is sometimes referred to as the bell curve. Okay, so sometimes we don't just want to look at the normality of the entire data set, sometimes we want to look at normality within specific groups. So if we want to do that, it's the same process. So let's imagine that we want to look at whether the data are normally distributed among males and females. So we can go to Analyze again, then down to Descriptive Statistics, then across to Explore. And now I'm just going to transfer the sex variable into the factor list. And this time the output is going to be the same, but it's going to be divided into males and females. So I'm just leaving everything as it was before, so both selected here. Plots, same thing, histogram selected, stem and leaf not. Normality plots with test selected. So I'll go to OK. Okay, so this output starts here, this is the new output, and I'm going to go straight down to the tests of normality table again. And you can see now that this has 2 rows instead of 1, because the output is broken down into males and females. And we can see the same thing again. All of these sig values are above 0.05, so regardless of whether we look at the KS test or the SW test, regardless of whether we look at males or females, all of these values are above 0.05, indicating that the data when broken down into males and females, are normally distributed. And if we go down to the histograms support this. Again, this is quite symmetrical. This one's slightly weird that it has like this wide flat top, but it's pretty much symmetrical, pretty much in line with the sort of bell shape that we would expect for normally distributed data. And same thing here, it's not perfect. You know, we have these little points on the side here. We would want the biggest point to be in the middle and slightly smaller points to be on at these points here. But it's pretty much normally distributed. So you could argue that this histogram supports that the data for the females are normally distributed. And just to clarify, so at the top of the histogram it will say sex equals female, or whatever your variable is. And here it says sex equals male, so that's how you know which group you're looking at. Okay, so beyond that, we might want to also look at, are the data normally distributed among male dogs, female dogs, male cats, and female cats? So for this, the process is pretty much the same, but we have to do something else first. So what I'm going to do is use the split file function. So we can go up to data, then down to split file. Okay, so we've already looked at males and females, but we didn't look at whether that was dogs or cats. So now if we transfer animal into this box here, so I've selected organize output by groups, then we're going to transfer animal into this box here. And what this is going to do is going to divide any outputs we do after performing analyses into dog and cat. So it's basically every analysis we do, if we have this option selected, is going to be divided into dogs and cats. So if I go to OK, and then I'm just going to repeat the process we did before. So I'll go up to Analyze, then Descriptive Statistics, across to Explore, and this is already set up from before, so we still have sex and the factor list. So if I go to OK, we can now see that the output is divided according to the animal type. So this top part of the output refers to dogs, and we can see that we still have this test of normality table divided into males and females. So now this refers to male dogs and female dogs. And as per the previous tests we did, we can see that the data are normally distributed because these four values, these four sig values or p values, they're all above 0.05, indicating that the data for male dogs and female dogs are normally distributed. And then if we keep going down, we've got this histogram. Again, these sort of support what the tests have said. So this is pretty much symmetrical. There's a bit of stuff over to the left here, so it's not completely perfect, but it's approximately normal. And the same thing with this one here. Again, we can just look at these labels at the top of the histograms to tell what we're looking at. So animal, dog, sex equals male. Animal, dog, sex equals female. And then we just have the same thing. I'm just going to ignore this stuff. I'm going to go down to the next section of the output. So animal equals cat. We're going to go straight down to the test of normality table. Again, all these sig values are above 0.05, indicating that the data for the cats in the males and the females are normally distributed. And again, if we look at the histograms, this supports this. So animal, cat, sex, male. This is pretty much symmetrical. There's a bit of extra stuff over to the right, which means that these responses are a bit more frequent than we would have expected with a perfectly normal distribution. And then if we look at the cat, the female cats, we see basically the same thing. It's approximately normal, but it's not exactly perfect. This is how I would report it. So Shapiro-Wilk tests indicated that the data were normally distributed for the male dogs, the female dogs, the male cats, and the female cats. And I'll just get those p-values. So I'm just in the part of the output where it says animal equals dog, and it says sex below that. So I'm looking at the male dogs and the female dogs, and I'm going to report these values here. So these are coincidentally the same, although in reality they probably wouldn't be. So these are male dogs. So I've got male dogs here. P equals 0.854. Female dogs 0.854. Okay, scrolling past all this. Now I'm down to the cats, and we have the exact same values here. Bear in mind that this is artificial data, and in reality it's very unlikely that you'd have the exact same p-values for all of these, but hopefully you can see where I'm getting the values from. Every time I'm just looking at the sig value in the Shapiro-Wilk column of the test of normality table. Okay, so that's all for this video. If you have any questions, let me know in the comments and I'll get back to you, and thanks a lot for watching.